Okay, welcome back. We just finished example 3 in section 7.3, and now we're going to go on to example 4. So in this case, we want to find the z value such that 90% of the curve lies between negative z and positive z. So it's kind of a weird thing to think about, but we're going to look at it in terms of a picture as always. So I'm saying if I reach out and I say I want 90% of the curve in between my hands, what are the two numbers that are going to be here? And we want to look at them in terms of z-scores. Now remember, z-scores start at 0 in the middle, and they go out to 1, 2, 3 to the sides, and -1, -2, -3. And if we're reaching out 90%, we're certainly going to be reaching past 1. But we want to know how much further do we have to reach. Well, again, anytime you use percent, you're going to do the inverse. So we want to know inverse normal. Now the problem is the inverse normal only gives us everything from the left to the right. So if I did the inverse normal for 90%, it would not give me, as we call a stretch from the center. So I want to know everything from this left part and the 90% all the way up to this boundary, because that's the only one I can solve for right now. So the way to do that is I ask myself, well, if this is 90%, how much is left over? Well, on the bottom, there'll be 5%, and on the top, there'll be 5%, because that has to add up to 100. So we want to do the inverse normal. First of all, up to 5%, because I want this boundary. So 0.05, 0, 1, because we're doing z-scores. And then I'm also going to do the inverse normal for 0.95, because I have to go from 90 plus 5 all the way up to here, which would be 95, 0, 1. And that will give me my two z-scores. So let's use our calculator. So second bars, inverse normal. So we're going up to 5%. That's the beginning of the 90% stretch. And we're using 0 and 1 because the center is 0. Standard deviation is 1. And we get our z-score as negative 1.644. So let's record that. Negative 1.644, which is about right here, right? So I was a little bit past where I wanted to be. So it looks like I'm going to be about right there. And if we look on the other side, what do you think is going to happen? Well, I'll tell you what's going to happen. We're going to get the same number because we're stretching the other direction, and we're going to get positive. And you can go and do that on your calculator if you'd like. But since we're moving the same distance in both directions, we're going to get exactly the same value. So our range would be, if we were going to write this out, we'd say negative 1.644 is less than z is less than 1.644. And that is a range for a 90%. Later, we're going to talk about it. It's called a confidence interval. We're going to be doing those next week. Confidence intervals are when we stretch from the center out to the sides. All right, so example 5. Find a z-value that 3% of the curve lies to the right. So this one's a lot easier than the previous one, actually. So we want to know 3% to the right of z. So this is 3%. So this highlighted area. So if that highlighted area is 3%, remember we can only calculate the left side. So we want to know how far is it from here to here. So we're going to use our inverse normal of 97%, and again 0 and 1 because we're looking for a z-score. Let's go to calculator, second bars, 0.97, 0, comma 1. And if you notice up here, it says area, and then it says mu, and then it says theta. And that tells you um, the mean and the standard deviation. So 1.88. So that means that that value there, that z-score, equals 1.88, almost 2 standard deviations away from the middle. Because if this middle is 0, we had to go that way, almost 2 standard deviations to get to 97%. Okay, you go back, highlight a couple answers. This is the answer to this one. This is the answer to this one. Okay, number 6. And I think this is the last one I gave you. Find the z-value so that 35% lies to the left. So this one's actually the easiest one because you don't have to do any subtracting. Draw a curve. We want 35%, so I don't know, just predict. We want z, and we want this to be 35%. And again, we're working backwards. And this is 0 in the middle. So we know our z-score has to be negative because we're going to the left. So that's something we should know. Z should be negative. So I'm going to do my inverse normal for 0.35. Be careful when you do percent. Like in the example I did above, remember when it's 5%, you have to put a 0.05, right? Like in this example here, I'm highlighting. So be careful. Sometimes people put 0.5, and that means 50%. So 0.35 and then 0.1. And we'll go back, use our calculator. Look at my distribution again. For number 3, I need the area, which in this case is going to be 0.35. And then I need my mean and my standard deviation because I'm looking for z-scores. So negative 0.3853. So it's not even 1 standard deviation away. So it's going to be z is going to be equal to negative 0.3583. And that is a negative value. I forgot the negative. Not even 1 standard deviation away. So this is less than 1 standard deviation away. This would be negative 1. So again, I probably should have predicted a little bit over here. Get rid of this. So if this is negative 1, this is negative 0.35. Yeah, I wish we were in class to do this, but I at least want you to see this because if you take stats in college, which you probably will because most of you are not going to be math majors, and you do have to take math in college, so I suggest you take stats. You're definitely going to have to know about normal distributions, and this gives you a little bit of practice with it. And this is a little bit better picture of what I was talking about. When I start to do some of this predicting stuff, like that last one was 35%. So if you start to add up this number here, that's about 2.5, and this is 13.5. So all the way up to here is already 16%. Okay, and we were looking for 35%. So how much more do I have to add to that? Well, maybe another slice here, because notice it gets bigger and bigger and bigger. So if I add up all of this, if you go all the way to the middle, you get 50%, right? It's half the curve. So we were looking for 35%. So it makes sense that our z-score was somewhere between negative 1 and 0, which is this middle part. Okay, so it's always good to go back and look at the picture. All right, next video is on the central limit theorem, which lets us use a normal distribution as long as a couple rules are in place, and the most important of which is the sample size has to be at least 30. All right, thank you.